Thank you, Mike. Thank you. So, hi, everybody. Okay. So I already got my introduction, so I'm not going to repeat this. I'm based in Tuscany, so it was a long flight. Merge. We already got some information about Merge. We worked on SEO, AO, and data engineering. And what we focused on is to shape the future-proof platforms. We work with some big and nice clients. These are high competitive markets. And today we're going to go and speak about a few interesting stuff, how rendering and style affect the content and how that is seen from AI crawler and web crawler, and then a few edge cases. So if you see this badge on some slides, these are just not official information. These are based on my test or some personal assumption or non-official documentation. So be careful because this might change tomorrow or whatever. So let's describe my ideal world in terms of information. My ideal world in terms of information would be to have easy to get information, static information even, text-based information, and structured and semantic information. But the real world, the real web is more complex, is changing every day. And we have content in a lot of formats. We have a lot of rendering patterns. And we have a lot of features that you have to have on your website, and you have to support it. So our main job usually is to bring the gap, to build bridges between the ideal world and the real world. And search engines have spent some time to trying to tackle these modern web, trying to fix the stuff, and they started rendering. But this was one of the research we published last year with Vercel about AI rendering. And AI crawler, excluding obviously the full browser automated AI agent, weren't really crawling and rendering a lot. I spent a few days early this week, and this is the new table. You can see there are some new bots here. Obviously, this doesn't mean that they are rendering every time. They are capable of rendering. They are rendering with a very nice way with a full browser. But this doesn't mean that they are rendering 100% of the time. We also have other bots that are rendering already, but we didn't include here the flag, the green flag, mostly because we're waiting for more data. So with the rise of AI, we got a sort of reshift again. In the past, we had the shift when search engines started to rendering. And then we now have another shift. We also have this kind of new application. We have Atlas and Comet. And these are introducing new stuff. So if you use Atlas and Comet, you got your pages rendered, and you ask some information about those pages, then those pages are going to be present in your chat, even if you close Comet or Atlas. So the content is on ChatGPT and OpenAI and Perplexity server. And this is on the terminal service of ChatGPT Atlas. So you can even opt in for training data with your web browsing with Atlas. This is interesting. And this is something that I shouldn't do, but I spent some time with Wireshark, and you can see all the traffic that goes between Atlas and OpenAI server. And there are a lot of stuff. You can even decrypt those kind of stuff. At the moment, this is not decrypted for security reasons. Let's say that. I don't want to mess up. But the connection between Atlas and the server is quick. So it's pretty much the base of HTTP 3. However, it's good to remember that the crawling is not the only source of AI. So this is a good thing, to be honest. Well, let's talk about rendering. This is my thing. I really love rendering and all this kind of stuff. Search engine rendering has been a thing for a lot of years now. And they started rendering But with rendering, they didn't solve everything because we still have a lot of edge cases and poor implementation of website. The key difference between user rendering and automated rendering are usually the lack of interaction, the asset caching, and there are even some really weird edge case implementation. As an output of the rendering process, we can have a lot of stuff. These are the three main stuff: the DOM tree, the computed style, and the layout tree. The DOM tree are like the object you have on the page, the text, the content. The computed style are the style of that content. And the layout tree is the position and the dimension of those content on those elements on the page. And this is something that's really bugging me a lot. We don't do really that much with this kind of computed style and layout information at the moment. We talk about content above default and all this kind of stuff for years. And then I really didn't see that much done publicly on this kind of stuff in the industry. I get it. There are a lot of stuff, a lot of new shiny stuff that all people like to talk about because, yeah, that probably brings more money, but this is a cumulative games, and so we need to understand and to fix all the details because a good platform is built only on strong foundation, and every detail matters. If we talk about rendering, we need to talk about the viewports. During our rendering, if you want to render with an automated browser, you have to define a few configurations. And one of those is the viewport dimension. The viewport dimension is just the content that you can see in the browser. Your window, you can see that is the viewport. And these are some of the viewports that are from the main crawlers. We have other data, but these are obviously the most important one, let's say that. So you can see that are usually quite similar in terms of desktop and smartphone. And when we talk about viewport, this is probably the most important thing we have on rendering for Google. I already talked about the viewport expansion technique in the past, but this is a good refresher for the edge cases later. So the viewport technique from Google is the way they are changing the viewport to get the most content from a page. When Google is rendering a page, they use one of the two viewport configuration we have seen before, so or desktop or mobile. But then, after the initial load page, they check how tall the page is, and they change the viewport dimension to match that dimension of the page. Something like this. So they start with this viewport, they check, okay, the page is tall like that, and they change the viewport to match it. Why they are doing this? They're doing this to find the lazy loaded content you might have on the page. Because if you have the viewport matching the page, the lazy loaded content might start loading, and they end up with a complete page rendering and content. These are just a few additional notes. If the page is not taller than the viewport itself, the viewport is not changing. And the second one is that the viewport height resides only once. So if you're expecting an infinite amount of resizing, that's not going to happen. But let's just remember this, that changing viewport is not a common thing on the web. A developer usually is not expecting a user to change the viewport in that way, especially with a very big and tall viewport. So this obviously causes some edge cases. And yeah, and these edge cases are really gonna mess up stuff. So when things goes wrong, you might have two different problems, content mismatches and value mismatches. The content mismatches is when the crawler sees more or less content that it should be. And the value mismatches is when the content has a position or a different value than what it should be. Let's start with the first edge case. This is the most common one, so probably the easiest one, lazy loading. As we said before, lazy loading is usually implemented to keep your page quite light, and then you can expand the content of the page. If we factor in the viewport expansion, this is working like we've seen before. And the problem is that when you implement lazy loading, a bot usually don't expect an action from the, sorry, I messed up. The bot generally don't perform an action, don't scroll, don't click, and don't do this kind of stuff. So if you are implementing the lazy loading stuff, don't use those kind of action. This because they might never happen. Those are bad for web performance if you're not using passive listener. And the best solution for this case is the intersection observer API. The second one is the before and after pseudo-element. So these are quite nice element if you want to add some cosmetic content on your page. Usually people add this way for adding the quotes on a specific phrases or all this kind of stuff. But that content is not part of the DOM tree, so that won't be indexed. And if the content changes the meaning of the text itself, that's a bad thing because that's not gonna be indexed. So I've seen this kind of element used for snippet to explain some part of the page, and the snippet content weren't not included. So the suggestion here is quite simple. Just don't use before and after pseudo element to include real content. Just for cosmetic, it's fine. Then we have the heading. H1, H2, H3. If you listen to Search Off the Record podcast from Google, from the Google search team, they say this. They say that they use the style of the HTML heading tags to determine the relative importance of each one of these headings. So if you're using that H1 element on the top of your page in a very small way just to have your keyword stuffed in, and I mean, that's probably not going to have the major weight in terms of headings. Your H2 might be the most important one from Google. So when possible, and I underline when possible because I understand that sometimes it's not possible, respect the visual semantic of those elements. Well, when it's not possible, just know that the H1 element might not be the most important one. Display none. This is interesting. In the past, we talked a lot about display none, visual hidden, and whatever, but yet we never found a sort of solution. But when you use a display none on an element, that is not in the render tree, but is present in the DOM tree. What this means? This means that the content that use display none has no position and no dimension. So this is an assumption. If search engines or AI crawlers use the position of an element to say this content has a prominent position and has a value, a display none element, a display none content element has no value, or at least might be a bit less valuable than other part of content. So, as we say, display none has no position and no dimension. And if you want to hide some content, you can use the visibility hidden instead. This is because the visibility hidden retains the dimension and the position. It's just not shown on the page. From now on, things are getting a bit more interesting. Infinite scrolling. So there are a lot of websites that append content when you scroll. And they usually use the history API to change the URL. Something like this. So you start with article number 1 on URL article number 1. You scroll a bit. Article number 2 is pushed at the bottom of your page. You scroll again, again, and again, and then the history API is used to change the URL here. And then you keep going and going and going. And you can scroll for a lot of articles. You can get probably 10 to 15 articles, whatever. But the issue here is the history API is fine. You can use it on Google. It's not like breaking anything. But the problem is that Google will still use the first URL. So if you started doing this on the URL number 1, and you factor in the viewport expansion, so you have something like this. You have the URL number 1, article number 1. Google is expanding the viewport. The article number 2 is included, but the URL is still the number 1. So you have the content of article number 1 and article number 2 on the first URL. So that's not specific to the specific URL. And there are even other sort of implementation when you scroll enough, the content of the second article is replacing the first article. This is just to keep light the page. But if you factor in the viewport expansion from Google, that is interesting because you might have the content of article number 2 on the URL number 1. That is interesting. So with infinite scrolling, you might have showing up or having in the index the content of two different articles for a single URL. In some specific case, you might have the content of a different article on your URL. Be careful with the history API. And the solution for these use cases is just to use the user agent. It's the most simple way. You can use it on server side and on client side. If you use it on server side, you just don't include the infinite loading for Google. If you use on client side, you just block that function when you match the user agent. This is the most interesting one, the viewport hate trap. So a lot of websites use the viewport height and width to have those kind of very big image at the top of your page. You get the full screen experience. And those kind of images or elements are just fitting the entire viewport. You can see a few examples of these, for example, on the awaward.com website in the full screen category. But when you factor in the viewport, this is interesting because that element that might be an image is going to be the full width of the viewport. So if Google is just checking a very high page, let's say 100,000 pixels, the image will gonna be tall 100,000 pixels. And all the content, the most important thing is that all the content is going down, is going to be pushed down. So if, again, this is another assumption, Google and the other crawlers are using the above default content to define the value of those content, well, you might have a problem here because that content is not anymore above default, it's quite low on the page. So if you want to use the full element, the full screen element on the page, on the website, that is fine. I mean, it's looking nice. You just set the max height for that element. So if you are like 1,000 pixels, it's fine. Not more than that. If you mix stuff together, you might have something a bit worse than before. So you have the VH like before, and you know that lazy loading usually works like you have a lazy loading threshold. When the viewport is matching that lazy loading threshold, the content is loaded. But when you have a problem like this, the lazy loaded is never met. And so, yeah, I mean, that's another problem. To solve this, still, the max height. That's the solution, again. This is a bonus, because we need to talk about AI. Everyone needs to talk about AI nowadays. So this is a thing. Let's say you are using a full AI agent with a full browser that is rendering a page and whatever. That AI agent is completely capable of rendering whatever website you have, but those kind of, let's say, agents are non-deterministic. And so if you just ask a very vague question like, please, can you get me the content, the full content of this website, of this page, they might just not scroll. You get partial of that content. So be careful about that. A few additional use cases for this kind of layout information and style, because rendering is always taught us we have content or we don't have content, but there are a lot more stuff. The first one, we already seen that. We can do an analysis of the above default content and understanding what we have. The second one, this is interesting, a bit niche, but interesting. A company that has a lot of brand was interested in understanding if having two similar brands would diminish the value of those kind of differentiation. And that is diminish the value from a conversion rate point of view. So yeah, you can use the layout information to do that. We did that by comparing all the elements on the pages to understand, are these pages 100% similar, 90% similar, 80% similar? You can use the layout information to understand if when you do a one-on-one domain migration, if rendering is broken, if the rendering is not the same on both domain, you probably have, I don't know, a content security policy going on there that is blocking your JavaScript or a beacon or whatever. So this is useful. And then this is probably the most easy one. You can just use the layout information to understand if you have a big element that is covering everything on your page, that is an intrusive interstitial or a dialogues, obviously. So that is problematic. There are a lot of other use cases, but I don't have the time to include all of those. Conclusions. So not all crawlers render web pages. Even if a crawler render a web page, you might still miss part of the content. There might be some edge cases, so be careful. The Google Viewport expansion is not a standard technique, so yeah, that might break the web. That's fine. And please use more of the layout information and computed style in your day-to-day job, because yeah, those are really informative. You can use a lot for a lot of use cases. This is the link to the slides. You can download them, and yeah, let me know if you have any questions.